Hello everyone, welcome back to my channel. In today's video, we'll be diving into mathematics. We'll be seeing an important algebraic relation which will help us solve many problems which are usually asked in Olympiad exams. So here we start. So here we have the statement: if a square plus b square plus c square minus ab minus bc minus ac is equal to 0, then we have to establish the relation between ab and c. This is a common relation and it is usually asked in many competitive exams. So let's start solving it and try to find the relation between a, b and c if this holds true. So here we start. This is the given statement. Now I'll multiply both sides by 2. This side and this side. So we get this and it becomes 2a square plus 2b square plus 2c square minus 2ab minus 2bc minus 2ac is equal to 0, because anything multiplied by 0 is 0. So we can write 2a square as a square plus a square. So in the next step we have done that only. We have written 2a square as a square plus a square, 2b square as b square plus b square, 2c square as c square plus c square, and the rest remains same. You'll understand why we have done this in just a minute. So in the next step, we'll rearrange the terms a bit. So now we'll be rearranging the terms. So we have written this whole expression as a square plus b square minus 2ab. Here we have got b square plus c square minus 2bc. Then we have c square plus a square minus 2ca. So this reminds us that of the whole square identity, that is x minus y whole square is equal to x square plus y square minus 2xy. So this is what we are getting here. Here we are getting c minus a whole square. Here we are getting b minus c whole square. And here we are getting a minus b whole square. The whole purpose of this was to get the terms in the form of whole squares. That the reason is, for this whole expression a minus b whole square plus b minus c whole square plus c minus a whole square to be 0, we have to get these squares individually as 0. That means that a minus b whole square should be 0, b minus c whole square should be 0, c minus a whole square should be 0. Why we are doing this is because you have to understand, when we square anything, we always get a positive value. Any negative numbered square will always give the positive values. So if we'll add the positive values, then it will always come greater than 0. But we have to get it equal to 0, so these individual terms should also be equal to 0, which means a minus b whole square is equal to b minus c whole square is equal to c minus a whole square is equal to 0. So from here we get a minus b is equal to b minus c is equal to c minus a is equal to 0. So now we are heading towards the conclusion. So now we'll individually solve all the terms. A minus b is equal to 0, this gives us a is equal to b1. B minus c is equal to 0 gives us b is equal to c2. And c minus a is equal to 0 gives us c is equal to a 3. So from 1, 2 and 3, 1, 2 and 3, we can conclude that a is equal to b is equal to c. So this is an important relation that we get. When a square plus b square plus c square minus ab minus bc minus ac is equal to 0, then a will always be equal to b will always be equal to c. So here we have established the relation here. A is equal to b is equal to c. And here we have completed the question. And now I'll be explaining the step from the previous page a little bit further so that you can understand it better. Here we had concluded that a minus b whole square should be equal to 0, b minus c whole square should be equal to 0, and c minus c whole square should be equal to 0. This was because any negative number squared So if we score any negative number, for example -2, will give us a positive value. So here, if this is not equal to 0, if we suppose this is not equal to 0, then it will give us a positive value which will always be greater than 0. That is why we have said that a minus b whole square, b minus c whole square, and c minus a whole square should individually be 0 for this whole expression to be 0. I hope you would have understood. So, if you have understood the relation, now give this question a try. This question says that if real numbers x, y, z are such that x square plus 4y square plus 16z square is equal to 48 and xy plus 4yz plus 2xz is equal to 24, then we have to find the individual and precise values of x, y, and z. This question is somewhat based on the concept that we have just done. I hope you will try solving it and get the solution. I'll post the solution to this question in the next video. Thank you for watching. Like, share, and subscribe for more such videos.